fact, I know that myself. So with object-oriented programming, what essentially the benefits what we get is we have features which makes things simpler for us. Features like inheritance, abstraction, polymorphism, encapsulation. These features essentially make your application development simpler and faster. And these are the core pillars of object-oriented programming language. So as time passes, we'll see these features and we'll understand as to what the benefit of having these things in your programming language means. All right. So these definitions, on a high level understanding, these definitions are framed. What is the definition of a class? Class actually defines is a prototype of an object which are created. So if you have to create certain objects, you will definitely define any type for it. You will define a prototype as to how the object should be. So that is the class. And what object is? Object is a bundle of related state and behavior. When I say state, it means the data for that object, and behavior means the functionality what the object has. For instance, in every object we know that every object has some data on its own, and it will have some behavior. It does something. This behavior is about doing something, and this state is about having some information with it. All right. And method is actually a functionality, an ability of an object to do something. The behavior what I'm talking about is method. Every object will expose some behavior with some methods. Okay, and these discussions will have again in more detail as to what the abstraction, encapsulation, and inheritance means. All right. Well, abstraction primarily shows one feature of Java.
Could you please explain the method?
Sorry?
Could you please explain the method?
Method actually has functionality. What you do something, as I told you, this object has behavior, right? It behaves. It is something which is done. So this behavior is exposed by methods. The object has some functionality to do, right? It has some, a program is meant for doing something. Maybe you have a calculator application and you have a program, you have a function to add some, add two numbers maybe. So that addition is a behavior. It is doing something. Okay. So that something is done using methods. The behavior part of the object is exposed by methods. All right. We'll see in our examples as to how methods, we will write how do we write methods, and how do we function, how do we expose functions for the end users to use them. All right. And then encapsulation, actually we'll have much clear discussion on these things later on, but you don't have to understand anything from this now, except that encapsulation is actually a binding of data and methods. You are binding the data and methods into one object. All right. And inheritance means that you have some properties defined in earlier prototypes, blueprint or a class, and those properties you inherit to subclasses. Okay. And polymorphism just means that you can have more than one forms for an object. It means an object can expose more than one form. All right. So when we have some examples on these things, things will be very much clear. All right. So what are the benefits of having object-oriented programming? The benefits are your applications are having modularity. It means you will have modules for every functionality. Your big application is segregated into different modules. For example, you can have a module for calculating. Let's assume you have an online shopping application. So you have a module for performing checkouts. You have a module for billing, or you have a module for adding elements to your cart. So these modular approach can be leveraged in applications by using object-oriented systems. And information hiding is again one of the important features, because your information, which your data, it can be hidden from the end users. You can actually bind it. If you want to expose some data, you can expose it. If you don't want to, you can hide it. So that kind of feature is available by the use of object-oriented systems. And certainly you have code reuse. The code what you have written once can be used in your application more than one time by calling the same methods again and again. You can reuse the code. Alright, so that makes things easy for you, and your applications can be pluggable. When you have modular applications, you definitely will have features of plugging applications. You can use applications partially from one source and partially from another source, and you can plug them and you can create bigger applications. And that makes things easier for you to debug as well, as to if there is some certain failures. You will be in a clear understanding as to what component or what module is actually failing. So these are the primary benefits for why we actually adopt for object-oriented systems. All right. And these are some technology buzzwords, Java buzzwords, what you often hear about Java, as to why Java is very much, what you say, accepted across the globe. And these are some very high level features. Okay, we'll start. I mean, these discussions you might generally, if you open any textbook on Java, you'll probably see these words on the first page, that Java is very simple. Okay, and the reason why Java is considered as simple, because people have been working on different programming languages like C, C++ for ages. So what Java has done is it has leveraged the syntax of C and C++, and the same syntax is being used in Java. So that made migration of people who were using C, simpler. So that's why we consider this language as simple. This is portable. The applications which are written on one architecture, one platform, they can be used on other platforms as well, with minimum dependencies of platforms. All right, this is object oriented. We will have some discussions on that again later. Architecture neutral or platform independent means that applications which are created on one platform can be executed on different platforms. So that makes applications portable as well. And multi-threaded, Java has the best way of implementing multi-threading. It was not existing prior to Java. It has a unique way of having multi-threaded behavior, which actually came as which became a pioneer in programming languages. And after Java, there are several languages which had kind of taken that approach to implement multi-threading. It is dynamic. Dynamic means at the runtime, most of the things can take place. Like your classes are loaded at the runtime, objects are created at the runtime, the memory is allocated at the runtime. You no longer have to create memory in your code. You don't have to allocate what memory parts are being used in your code. So things are done dynamically. You don't have to bother about memory allocation and deallocation when you write classes. All right, and this is a very high performing application language, because applications which are created are architectural neutral, and they are robust, and they are very dynamic. So that's why the performance is kind of faster, and good performance is exposed. And then distributed, robust, I told you, applications which are created in Java. All the applications are running on a virtual machine. We'll come to that, what virtual machine is. And the virtual machine makes the applications very robust. And if something fails in your application, to be the worst case expected is you will see that your virtual machine is terminated, which is just a process of your system, and which can be restarted again to restore your systems back. So that is the robustness towards what Java can expose. And distributed computing can be enabled by Java. you actually can create applications for different systems, different environments which run sequentially. For example, distributed computing means your application, part of the application is hosted on one server and part of the application is hosted on another server, and you have a conveyed clustered environment which will enable things working for you. So that's the goodness of Java. You will not have to use one application on your whole application on a single platform, but rather you can have distributed platforms, distributed components. For example, you can implement presentation logic on one server, on one machine. You can implement a business logic on another machine, and you can have a clustered environment. All right. And Java obviously provides good amount of security with respect to your data, security with respect to system threats, viruses and all, because Java applications are running in a sandbox and they are not using the process directly, but rather a virtual machine is involved in executing your code base. So Java applications are pretty much secure as they are not exposed to any system threats like viruses and all directly. Right. These are some data types of what Java uses. Primitive data types. We have an int, okay, a byte, short, int, long, float, double, char, boolean, and these are similar to what you have used in C language or C++ if you have worked on that. The difference is in Java you have a standard size of these data types. So it will no longer vary across your platforms or your architecture, but it is a standard one. Java has defined these things and every system, every platform will support these data types. A byte will be 8-bit, a short will be 16-bit or 2-byte, int will be 32 bits, long is 64-bit and float is 32-bit, double is 64-bit. Alright. And character data types, Java has come up with 2 bytes, that is 16-bit data type, unlike C and C++ where it was using 1 byte for a character. The difference is, why do we have 16-bit is in Java we are using Unicode format for characters, which means that you can include characters of any language across the globe because we have a support for Unicode. Alright. Unicode character set includes the characters of all the languages in the world. So using this you can actually generate some content in your Java applications in Chinese or in English or in Indian languages like Tamil, Telugu or Sanskrit. So all those characters can be included. So that is a good thing, and that actually makes a beautiful feature of Java as to internationalization. You already might be familiar that there are plenty of applications which are already supporting internationalization for us. But if you happen to visit a Google page, you can actually select what language you want to render the results back. So all those features have come up with this Unicode support by different languages, and Java obviously supporting Unicode language, Unicode character set is a good thing for us. And lastly, the Boolean data type is used for declaring information like true and false. So it's a different data type. You don't have, you will not use a non-zero number as true and zero as false in Java, what we have been doing in earlier languages. So Java has a predefined data type for it, which is Boolean. It takes values true or false. That's it. So if you have to have any Boolean conditions, you will use Boolean data types. And these are some operators in Java. These operators are pretty much similar to what you have used in C++. No, nothing much is differing here. These are arithmetic operators: addition, subtraction, multiplication and division, and modulus operator. And relational operators: less than, greater than, equal to, greater than, equal to. Logical operators: short circuit operators and non-short circuit and assignment operators. Ternary operator is for understanding having three operands, that is if then else kind of conditions can be exposed. Then you have increment operators, plus plus, decrement operators, minus minus. These are pretty much the same what we have discussed in what we have seen for ages. There's no difference in C and C++ and Java for this. So we will have some examples on this as well in immediate future now. All right. Right. So time comes for us to have one hello world application, which is actually a formality to get started in this format. So let us start with one example. As I told you, I will be using a simple plain text editor for this purpose. I will not directly use Eclipse for some days. So if you have to write a code in Java, you will have to define a class. So let me say name this class as hello world, and everything what you will be doing in your application will go inside a class, inside this class itself. So everything is inside this class, and the functionality what you will add to your application will go inside methods. So I'll add method for this. So for keeping it simple, because this is the first application, we will start off with the main method, and the main method signature will be like this. This is the signature of your main method. Why this long signature is used, we'll discuss again later. We'll come to a discussion when we'll address these things. But for now, we'll just think it that this is the signature of your method. This has to be like this. And this method will again have open brace, which opens your code, and a close brace, which will end your main method. So this is the starting and this is the ending of your main method. And in goes all your statements. In this, all your statements are encapsulated. So let me write the statement to print something. I want to print system out or print line, right? Then open curly brace, quotes, close the quotations, close the braces, and terminate the statement by using a semicolon. Semicolon is used for terminating your statements, and this is used for closing your method, and this is for your closing of your class. Your class is closed. Alright, this is how your Java application looks like. Everything will go inside a class. If you have some comments to be written, you will have comments in form of two slashes, and I'll write comments. I'll save the file. I'll just write the name of the file here. Hello world.java. Alright. So this command will not be compiled and will not be executed. It is just a command to be written inside your code to describe something about it. Alright. So let me actually run this. Now I'll have to save this file in a location where we will be working. So I'll do one thing. I'll simply go to I'll create a new workspace for you. And the file name what I'm saving is hello world.java. Make sure you're appending codes to this, because it doesn't treat it as a text file. Because if I don't add this code, it might treat this file as a txt file. Let me save this. Alright, the file is saved. I'll navigate to the folder where I created this, and from my command prompt, my workspace slash alright. So for compiling your code, for making it in a workable format, we will have to write java c. We'll issue this command hello world.java. So when you run this command, it will compile your code and convert it to a bytecode format. Let me show what has been done. So this is the class what I have written, hello world.java, and this has been compiled to hello world.class. The class has been generated for you, and using this class you will now run your application. So how do you actually work is, you will say java hello world. When you run this command, this will implicitly mean that you are actually doing java hello world.class. It's like saying hello world.class. You are calling the class. But JVM by default understands that you are actually calling the class, so you don't have to specify this. You are specifying java hello world. It means you are calling that class itself. And when you press enter, you will actually see the statement being printed. A very basic example, you might have seen this kind of one several times, but just for the sake of discussion we have this. So any questions on this so far? I know this is very much basic, but there might be someone who is not very familiar on this. And is there anyone having any question? Hello?
No, it's fine.
Okay. So, all right. So I think you are then maybe, I mean, if you are good till here, I would definitely catch up my speed and understand as to, I mean, how things can progress from here. Okay, good. So this was your very first example uh, on this thing. So if I happen to add some the way you declare variables in Java, if you have to use any variable, maybe you'll have int a. Let me go with another example for this purpose. Like this. Before that, we'll see how to work around on these things. How to execute a Java program? We have the Java source file, which we converted into bytecode, the .class file, using the Java compiler, Java C. We have given the class name. It converted that to the Java, the .class file. Now this .class file is actually a independent, platform independent bytecode. Okay, so this is now compatible for any OS like Windows, Unix, Mac OS. The reason is the Java compiler. Once you compile your Java code, once you compile it, it actually becomes it has instruction set which is understood only by JVM. It will convert it to instructions which are understood by JVM, and a JVM is required for executing your Java code. So this will actually take care of running your Java code, and the JVMs are available on every platform. Right? JVMs are available on every platform. You have JVM on Windows, Unix, Mac. You have JVMs on your mobile phones, on your PDAs. So that makes actually your application execute on any system which has Java installed. Right. So this is what we have done just now. We have worked with Notepad editor. Save it with .java extension, open the command prompt, and just do like this. Alright, so let's understand about Java platform, Java, the whole overall architecture, and what Java these idioms are. Like you might have heard of this JRE thing or JVM and all. So how it actually behaves. These things are just a layer on your hardware. This is your hardware, your system, which has your processors, your microprocessors and all, and on that your OS is installed. You have different OS flavors, Windows, Unix and all, and on that you have a Java runtime environment installed, JRE. Right, this JRE runtime environment is responsible for executing your Java applications on any platform, on any machine. JRE includes again two components. One is your Java virtual machine. Java virtual machine is the JVM, is the basic program which is the initiator of your applications, and on top of that you have Java API or the classes which are required to function. In our example, we have used classes here like system. This is one class of Java. Okay, and a string. This is also one class of Java. So these classes are available in libraries. Okay, and that library is part of your JRE. And wherever you have these two components installed, you will be able to run your Java applications on any machine. Now with this concept of JRE and JVM, Java has spread to different types of devices. Now Java devices are almost everywhere. It has been estimated in a recent survey. In fact, it is not even recent. It has been done in 2010 or something. The survey says that the number of devices which are using Java are more than the number of people on this earth. Okay, it is definitely more than 10 billion devices currently. So this is phenomenal. This actually makes your applications reach a wide range of audience. All right, and nowadays the Java applications are kind of in our instincts, in our day-to-day activities everywhere. So that is the spread what you have, and that is the reachability. So let us understand what this JVM functionality is, what the JVM does for us. These are the different modules what are available in JVM. They are responsible for different activities. Okay, JVM has a class loader which loads class for you. Class loaders, they have to load classes. For example, our application had this class called hello world app. This is one class what we have written. So JVM has to load that. Then we had used a system class called string, which is available in Java API, and we have used another system class called system, which is also available in Java API. So there are three different classes used in one simple example. This is a very basic example, right? But we are using three classes. These classes has to be loaded, and that loading is done by your class loaders in JVM. There is a class loader. In fact, there are different class loaders available in JVM, and it loads the class. And after it loads, there is one application which actually verifies the bytecode. The bytecode verifier will verify the authenticity of your bytecode before actually executing it. Alright, before executing it, it will verify whether the source of this bytecode is a Java compiler or not. There might be cases if you actually tamper the bytecode, the tampered bytecode will not be loaded into the JVM. It will simply discard it. It will ignore it. All right. So these are the two applications which function before the before your application starts, and then you have execution engine which will have these three components. In fact, these 5 components. What I have listed here. JVM interpreter is the one which interprets your code. It generates a response based on simple instructions. Okay. And JIT compiler, just-in-time compiler, it is this is actually again a compiler which is internally available to JVM, which will make your interpreted code. If you want to have some system dependent code, I mean, it's not an optional though, but there are cases where interpretation will behave slowly. All right. For example, you have very long loops. You have loops to execute, and to make that faster, I mean, it's obviously recommended that your application has some native dependency. So JIT compiler will actually compile your code to native compiler, but not every code. There are some things which are compiled to native code, and that native code is executed to make your things faster, to make your execution faster. Because conventionally interpretation is slower when compared to execution. Okay, Java has interpreted style of executing. So JIT will actually make things faster by converting it to native code. And then you have a thread manager which will manage different threads of your application. Now this will actually be helpful if you have systems which do not support multi-threading. Initially, before, I mean, currently we have almost even our phones are multi-threaded. We have dual core or octa core. We have plenty of cores in our mobile phones as well. But there were days when we had single threaded or single process based systems. In those kind of systems also, Java had its own thread manager. Okay, and with this thread manager, Java used to execute multi-threaded applications. And then there is a memory management area which deals about this area of allocation of memory to stack, heap, method area, and register area. This will actually take care of every part of your memory allocation and deallocation inside your applications. So the developers are now free from doing these things manually in their applications. Rather, it is done automatically. The memory allocation and deallocation is taken care by the platform itself. Java does that for you. All right. And then garbage collection is one of the star features of Java. This actually lessens the burden of the developers from deallocating the memory. In fact, the objects what you create at the runtime, those objects are taken care by garbage collector, and garbage collector will take care of deallocating the memory which is occupied by unused objects. Now, they are objects which you create and you forget and you leave them. So those objects are kind of cleaned away by garbage collector. Alright, so this was pretty much about the theoretical discussions what we had. We will not have much of theory now. Going forward, we'll just have some, we'll now understand the conditional statements of the flow actually will be like this. We'll discuss about these conditionals, if else statements, switch statement and all. The next we'll discuss about looping mechanism. Yeah, we'll do iteration statements and loops and all, seeing while loop, do while loop, for loop and stuff. Alright, and then we will come to the arrays part, where we'll see actually what an array can be done. This is if you might have done some programming in C or C++, you are aware of how if else actually behaves. Okay, still we will have some condition. We'll take some examples now. I'll take some examples on operators. If you have to declare and initialize a variable in Java, you do this statement. This is declaring a variable to be of integer type. You declare it and you initialize it. This is pretty much the same thing what you do in two steps. If you declare and initialize like this, int b, and you do b equals to 20. So you are doing what you are declaring in one step, and initializing. Alright, so an example, a simple example of writing your if statement. If a greater than b, so you will write Boolean conditions here, which will either return true or false. A greater than b or a less than b, this will return either true or false. And you will have again braces to separate stuff here. You will say system.out.println a is greater and you will have also else statement. You can, if not, this condition is not true, then maybe print b is greater. Alright, so in this we are seeing the example as to how to declare variables and initialize them. Alright, and then we'll see how to write Boolean statements, and you will use the Boolean statements in conditional statements to perform some condition. So this will actually compare these two operators, these two operands. Will compare the operands 10 and 20, this comparison operator, and this will print if it is greater or less. So let me save this with the same class name in my workspace. Right, Java C operators demo.java, compile it. I don't have any errors while compiling, so it means the syntax is appropriate. And if I run it, I run by saying Java operators demo, and yeah, I see I get the result that saying B is greater. The reason is because B is actually greater. Alright. So now what I expect immediately from you in this, after this exam course, I mean this class is done, you will use these operators what we have seen in the initial slide, these operators, and come up with examples on these operators. Okay, so that will be your assignment for the day. Work on all the operators with examples and come for next session. So what you will do actually is you will use these operators in your example, like for example I have used condition here. I can simply use addition operator, sub multiplication operator, and display that. So now print line sum is plus a plus b okay, this has to be a comment. Right, fine, and this sum is 30. So write example in which you are using the other operators also, these operators, and if you have any questions on this, we'll address this tomorrow. The reason I did not discuss every operator is these are not new to Java, and they are very much the same what we have used earlier also, and quite simple. If you run some examples on that, you will understand it. What I will do now is I'll create a shared drive. Uh, I'll create a shared drive on using a Dropbox. Okay, and in that drive we will have our recordings uploaded. I'll also upload the session examples what we do on a day-to-day basis. The examples what I'm doing here, I'll upload those examples, and I will also have a folder. In that I'll have a directory where you will submit your assignments. So I'll show you a sample one. For example, I have another training which is happening in some other time. So there is a folder called assignments. This is a material book. This will be done later, and here we'll have recordings and session examples. So this kind of folder I'll share with you for this batch, and you will have your assignments submitted by creating your own folders here. All right, and in that you will submit your assignments. So we discussed till here. That will be so that's it pretty much for today's session. From tomorrow we will continue with some hands-on on every concept, and we will have in fact more such files. Today we just had 2 files created, but yeah, today being the very basic session. If you have any questions, come up with that tomorrow, and Okay, if you have any questions, we can address that now also. So I'll stop the recording and take questions from you now.